Okay, I want you guys to just literally follow the notes and take notes. Up at the very top of your paper, let's write this. So we're going to have f of x. We're just going to follow kind of what we did last time, but add a little to it. So remember, we did f of x equals, and we had negative, but now we're going to add an a in here, and then f of parentheses negative b parentheses x plus or minus h, and then plus or minus k. Okay, so let's go through all this. Remember that f of x is our function, and this f is just denoting, like, this could be any parent function. Any parent function. Okay, so let's go through this. We're just going to go left to right. This negative, if you can remember from last time, this reflects the x-axis. So this is going to negate all of the y values. Okay, now A. A is a new term. We haven't worked with it before. So let's see, let's do it in blue. So A here, A is going to be, it's either a vertical stretch or compress. Okay, and the way that you know if it's a stretch or compress, so if A is greater than 1, okay, so if A is greater than 1, that makes it a stretch. And if A is less than 1, it is a compress. Okay, if A is greater than 1, it's a stretch. If it's less than 1, it's a compress. I gotta write smaller. Okay, so then the negative inside, we talked about this last time. This is a, I'm gonna come down here. This is a reflection across the y-axis. So this is reflecting the y-axis. You should be writing all of this down. You want all of this. So this is gonna negate the x values. Okay. Now B, again, B is a new term. We haven't talked about B before, so let's do B. So B here is going to be the horizontal stretch or compress. Now there's something weird that happens with this, stretch or compress. I have to squeeze it in there. So we have to flip it. Here, I'm going to just draw another arrow. So we have to flip this. Flip it. But in order to see if it's a stretch or compress. But if we just look at it, ignore the flip for a second. So if B is greater than 1, it is a compress. Okay, if B is less than 1, it is a stretch. And then I just want you to write in parentheses, flip. Okay, you have to flip it. Okay, and then we've talked about H and K. So H, this is where you go left or right. And remember, minus is right and plus is left. And then K is up or down. Okay, so minus is down, plus is up. Okay, so if we look at this equation right here, we just need to describe the transformation. So, well, this negative right here, this is reflecting the x-axis. We've done a lot of this in the other assignment, right? The other negative is reflecting the y-axis. Okay, now the 2. Okay, the 2 is on the inside of the square root, which means that it is a horizontal, either stretch or compress. So I need to look at it. It's a 2. Now I'm going to flip it. Okay, so remember how I said flip it over here? Well, first, B is greater than 1 here. which means that this is going to be a compress. But if I flip this, so this is going to be 2 becomes 1/2. This is going to be a horizontal compress by 1/2. Okay, you flip it. You always flip it. And then this goes right to and down 1. Okay, all of this is going to go away. So take a picture, write it down, whatever you need, because when I go to the next slide, this goes away. Okay, hopefully we're good with that. Let's do another problem. So let's do this problem here. So this time, this negative here is reflect across the x-axis. The 1/2 is on the outside. Okay, so if it's on the outside, this is going to be a vertical, and it's less than 1. So this is a vertical compress by 1/2. The plus 1 moves this left one. And the minus 2 moves it down 2. Cool. Okay, again, this is going to go away. Hopefully you've written it down. So then let's look at this. So if we want to write the resulting equation, I'm just going to write it on each line here. So if we vertically compress by 1/2, well, this means that our A value here is 1/2. Okay, so this is going to be f of x equals 1/2 x squared. Actually, I want to do this like this. So f of x equals 1/2, because that's the vertical compress, and then x squared, because that's our parent function. Okay, reflecting across the x-axis, this is a negative on the outside. Okay, so we're left with f of x equals negative 1/2 x squared. Cool. Then we're going to go right 2 units. So right 2, this is going to be a minus 2 on the inside. Remember, if you go right or left, that's on the inside. So this is going to be f of x equals negative 1/2, and then x minus 2. It has to be on the inside, okay? I remember looking at some of your guys' papers last time, and I saw this mistake. And then the squared goes on the outside, okay? And then we're going to go up 1, so plus 1 on the outside. So we're left with f of x equals negative is our reflection. 1/2 is our compression. The x minus 2 is the right 2. The squared is from our parent function. And then the plus 1 moves this graph up 1. Cool? Okay, let's do the next one. So this one. So if we're going to compress horizontally by 1/3. Okay, if we're compressing by 1/3, we have to flip this, okay? Remember when I wrote flip? Hopefully you wrote that down. That means that our B value equals 3, okay? So in our equation here, that we're working with the absolute value, we have f of x equals the absolute value of 3x. That gives us that horizontal compression by 1/3. Okay, and we'll talk about what that means in just a second when we're actually graphing this. Okay, reflect the x-axis. Well, that's a negative on the outside. So we're going to have f of x equals, we have all this stuff still, but then the negatives on the outside and the 3 from before is right there. Okay, and then we're going to move left 2, which means I'm going to have plus 2 inside. Okay, so if I move left 2, we have f of x equals, let's write everything in here, negative absolute value of 3. Now, this is where people are going to make mistakes. You have to put parentheses here. Okay, so that's x, and then we have the plus 2. Close the parentheses, and then close the absolute value. Okay, and then if we move down 3, that's a minus 3 outside. I'm not going to rewrite this. I'm just going to put minus 3 right here. Cool. Okay, let's actually graph this now. Okay, so this is where you need to look at that paper that I gave you last time that we filled out all the stuff on. Okay, so we're going to look at our absolute value equation. So our absolute value equation, first, before we even do that, let's write all this stuff that's happening here. So this is a reflect across the x-axis. This is a vertical compress by a half. This moves it right 1, and this moves it down 1. Okay, so let's look at our table. So we're going to have our XY table here. I'll just draw it off to the side. X, Y, and remember absolute value was this. Okay. So here, the first thing we're going to do, we always just work left to right. So if I'm reflecting the x-axis, well, typically this looks like this, right? If I reflect the x-axis, it moves down, and now it looks like this. That changed all of my y values. So all of my y values get negated. Okay. Now, if I am vertically compressing something, so let's think about this for a second. So vertical is up and down. Okay, if I am, so say I have the absolute value equation here. If I vertically compress it, so that means I'm pushing in on it like this. It ends up looking like this. Okay, it gets like, that wasn't the best picture, but it gets like fatter. Okay, it's like, imagine your hands are straight up and something like pushes them down. Your hands are going to become straighter, right? Versus if we were to take that same absolute value equation and pull it, stretch it, it's going to get skinnier. Okay, so if we're vertically compressing it, well, we need to figure out vertical. That is our y values. Okay, so vertical is our y values. I'm going to multiply all these y values here by a half. So vertical is our y values, horizontal is our x values. So this is -1, -1/2, 0, -1/2, -1. Okay, and then I move right 1 and I move down 1. So if I go right 1, down 1, that puts my new center point right here. And I'm just going to think about this as like my new midline. Remember, like back to the trig functions when we would just draw new midlines. And then we literally just have to plot these points. So we have -2, -1, -1, -1/2, 1/2, 1, 2, -1. So it looks like this. Okay. All right, last one. So let's look at this cubic function here. So this time, let's write everything that's happening. So this is a reflection of the x-axis. This is a horizontal, and it's going to be a stretch because we flip it. So if we flip this, we end up getting 3. So this is a horizontal stretch by 3. Okay, and then this moves it left 1, and this moves it up 3. Okay, so pull out your paper. Let's look at the cubic function here. So we have x, y, and I went from -2 to 2. This is -8, -1, 0, 1, 8. Now, if I'm reflecting the x-axis, same as before, that negates all of my y values. So this becomes a positive, positive, negative, negative. Now I'm horizontally stretching by 3. Horizontal is this way. Okay, so if I'm taking, let's just take our parabola. I know this one isn't a parabola, but if I stretch this, that makes it like fatter, right? Looks like that. Whereas if I compress the parabola, it's going to make it skinny. Okay, so it has like the opposite effect of what the vertical stretch and compress does. So horizontal stretch by 3, I'm going to multiply all my x values, because horizontal is the x values, by 3. So this becomes -6, -3, 0, 3, and 6. Okay, then I move left 1 and up 3, so this is my new starting point there. Okay, and then we literally just plot points. So -6, -8. So let's see, -6, -8. So it'd be like right there. -3. Oh, wait. Wrong. I did it wrong. So it'd be -6, +8. So that's off our graph. I'm not going to graph it. -3, +1. So 1, 2, 3, up 1. 0, 0. And then I go 3, -1. So 1, 2, 3, -1. And then 6. So 3, 4, 5, 6. -8. 1, 2, 3, 4, 5, 6, 7, 8. And that's what that graph there looks like. Cool. Okay, I hope this helped. Please do your assignment. Be good for my sub. Thanks, guys. Wish us luck at state. That's where we're at today. So if you know any of the girls on the golf team, I can tell you who. Savannah Romney, Victoria Romney, Ellie Whitehead, Bella Bowman, Lainey Ross, and Alyssa Meadows. Wish them luck. We're playing hard at state right now. Okay, bye, guys.